Hi, okay, so you asked about this question right here, and I will try to help you figure this out. Side note, I have not actually done this question yet. I only put it in decimals to find out what point m is. Okay, so this question has a mixture of both finding stationary points as well as finding the area between graphs. So the first thing to do is to just read the question. It says that we have this curve, and then it's from 0 to pi radians, like that. And then point M is a maximum point, and OM is a straight line. This will be pretty important later. So we want to show that the area of this region right here is this weird looking number. So because the number is like this, notice that it's not like in decimals or whatever, or 2, 3 significant figures. It means that we're going to have to use exact values for everything. So that's going to be a bit painful, but oh well. Okay, first things first, point M is a maximum point, so we probably want to find this point M in the first place. To find a maximum point, we have to recall that whenever you have a maximum point, the derivative at that point is equal to 0. So first things first, let's go ahead and find the derivative of the curve. So we have y is equal to 4 sine of x over 2, and then after that minus x. Okay, so let's find the derivative. This is going to be 4 times. The derivative of sine is cosine, so we're going to have cosine of this. But we're not done yet, because notice that the inside here is x over 2, not x. So we have to multiply by the derivative of the inner function. The derivative of x over 2, the derivative of x over 2, well, you can think of it as the derivative of half x. So it's going to be equal to half times the derivative of x. So that's equal to half times 1, so that's half. So we're going to have to take this quantity and multiply by half. Okay, but that's not the only thing that we have to differentiate though. We still have to differentiate x, and that's pretty easy. The derivative of x, as we've just mentioned, is equal to 1, so minus 1. So let's simplify things a little bit. 4 and half, so this will become 2, meaning that this is equal to 2 cosine x over 2 minus 1. Now, remember, this is the derivative of the curve, and we want to find m, which is the maximum point. So one thing you can write down, I'm not sure if you have to, at stationary points, dy dx is equal to 0. So this means that 2 cosine x over 2 minus 1 is equal to 0. Okay, here we have a trigonometric equation. We know that x is between 0 and pi inclusive, and everything's in radians. So let's park that aside. Let's first isolate this cosine x over 2 first. Let's use a different color. So let's add 1 on both sides, and then we divide by 2 on both sides. We add 1, so this cancels out. We divide by 2, so this cancels out, which means that we get the cosine of x over 2 is equal to, what is 0 plus 1 divided by 2? Well, that's half. Okay, before we go about solving this equation, we have to remember that our initial range here was 0 to pi for x. But here we have x over 2, which means that what we will need to do is to change this inequality such that it is in terms of x over 2. What we can do is divide by 2 throughout. So we get 0 less than or equal to x less than or equal to pi over 2. Oh, sorry, x over 2. So this is the range that we're working with. So notice that the cosine is positive, and anyway, x over 2 must be from 0 to pi over 2, so therefore, because one way you can write it is since 0 less than equal to x over 2 less than equal to pi over 2, therefore x over 2 is in the first quadrant. Because remember, when you have something like this is 0, and here's pi over 2, here's pi, 3 over 2 pi, and then 2 pi. Oh, 3 pi over 2, I mean, sorry. Yeah. Alright, let's go ahead and find the basic angle. The basic angle is, which you might also see called alpha, is going to be the inverse cosine of half. Let's use our calculator. Remember to change it into radians. This gives us a not very nice number, so we'll probably need to do some work. Let's go back to our triangle. Oops. Our 30, 60, 90 triangle, something like this. This has a side of 1, this has a side of 2, and this has a side of root 3. We want it such that the cosine of some angle is equal to half. Well, we see that if we assign it to be this angle, the adjacent side is 1, and the hypotenuse is 2. So the cosine of this angle right here is equal to half. What is this angle right here? Well, it is going to be 60 degrees or pi over 3 radians, which means that the inverse cosine of half is equal to pi over 3 radians. Do note that radians is not a unit, but I'm just gonna write it here. Actually, we're done, because it must be in the first quadrant, so therefore x over 2 is equal to pi over 3. There are no other considerations. Because it's not in any other quadrant. So therefore, x is equals to 2 pi over 3. So this is going to be our point on point M. So this is going to be 2 pi over 3 and then something. So let's go ahead and find out what this y coordinate is. Actually, do you need to? Yes, you need to. Alright. So let's sub in. Sub x equals to 2 pi over 3 into the equation. You get y is equals to 4 sine of, in this case it's going to be 2 pi over 3, then the whole thing, this thing, divided by 2, right? Yeah. Then minus pi, minus x, which is going to be equals to minus 2 pi over 3. Okay, let's simplify this monster looking thing right here. We can see that it's equal to 4 sine of 2 pi over 3 divided by 2. So that's equals to times half and then minus 2 pi over 3. This 2 will cancel, so we are essentially finding sine of pi over 3. Sine of pi over 3 is going to be the sine of this angle right here. The sine of that angle is root 3 over 2. So what we get is 4 times root 3 over 2 minus 2 pi over 3. To simplify, this becomes a 2, this becomes a 1, so this becomes 2 root 3 minus 2 pi over 3. This is going to be the y coordinate of point M. Okay. Technically, if you were not given the graph, it's a good idea to check whether this point is a maximum point or not. So, for the sake of practice, let's go ahead and do that. So let's go back to dy dx. It is going to be 2 cosine x over 2 minus 1. So it's going to be 2 cosine x over 2 minus 1. This is dy dx. If you want to use the second derivative test to check if it's a maximum point, we go differentiate it. This constant is just going to be 0, okay, but so we don't really need to care. The derivative of cosine is negative sine of x over 2. Don't forget the chain rule. So divide times the derivative of inner function, so that's half. Notice that this and that will cancel. So essentially what you get is going to be negative sine of x over 2. Now let's go ahead and sub in. When I use this notation, it means that I'm going to sub in x equals to 2 pi over 3 into the second derivative. So I can actually just use my calculator. But if you want, actually no, you don't need to. So this is going to be the negative sine of, again, it's going to be 2 pi over 3 divided by 2. So it's times half. See that the numerator and denominator have a 2. So it's just asking for the negative sine of pi over 3. Negative sine of pi over 3, as we have mentioned, is going to be root 3 over 2. So what we get is equals to negative root 3 over 2. This is less than 0. This means that the derivative, the value of the derivative is decreasing. Notice that if we have a maximum point, at first it's a positive value, it decreases, it becomes 0, and it gets more and more negative. So therefore, by the second derivative test, you got 2 pi over 3, and then after that it's going to be 2 root 3 minus 2 pi over 3. 2 root 3 minus 2 pi over 3 is a maximum point. Okay, great. So we have found out the coordinates of points M. Next thing to do is to integrate, because we want to find the area of the shaded region, so that means that we probably need to do some integration. Now, the problem is, this area is not like a normal graph where it's just, between the x-axis and the graph and the line like this. It's between two different lines. It's between this curve and this straight line. So what should we do? Well, what we can do is this. Take a look at the integral of this region right here. Okay, so this includes this shaded region that we want, and this white section. Notice the white section, the part that we don't want, is actually a triangle. Which sides we can actually determine. If you look closely, and I just do something like this side right here is actually just the distance between the origin and the x-coordinate of M. So this is 2 pi over 3. Whereas this is the distance between the y-coordinate and the value 0. So this is going to be 2 root 3 minus 2 pi over 3. So the area of the triangle, that's area of the triangle to remove is equals to half times the base, which is 2 pi over 3, times the height, 2 root 3 minus 2 pi over 3. Alright, let's go ahead and do a little bit of simplification. This half would get rid of this 2. So what we have to do is distribute this pi over 3 to each of these terms right here. So this is going to give 2 root 3 times pi over 3. I don't know, you can leave it like this if you want. Minus 2 pi squared over 9. So this is units squared. Just to check, seems about right. Okay. Now the next thing to do is to integrate from here to here, because we want to find this region right here. So let's find the area. Okay, this is going to be the integral. Our lower bound, we are starting from the origin, so that's 0. The upper bound, we are stopping at the x coordinates of point M, so that is 2 pi over 3. What we are integrating is going to be 4 sine, I like to use brackets, x over 2 minus x dx, because we're integrating with respect to x. Alright, what does this give us? Well, this is going to give us, okay, let's integrate sine. So we know that when we differentiate cosine, we get negative sine. So when we integrate sine, we get negative cosine. So it's going to, so this is going to be negative. Oh, actually, let's start with this first. 4 times negative cosine of x over 2. However, we have to multiply by 1 over the coefficient of x. The coefficient of x is half. So something like this. Then we got to multiply by all this. Alright, next we have to integrate x. That is pretty straightforward. It's just going to be x to the power of 2 divided by the new power, 2. We're going to integrate from 0 to 2 pi over 3. Let's do some simplification. Okay, this is a really weird looking thing, so let's work on that first. What we can do is multiply the numerator and denominator by 2. So half and 2 cancel out. So we just get 4 times 2, which is going to be 8. Don't forget the negative sign. I forgot that. Cosine of x over 2 minus x squared over 2 from 0 to 2 pi over 3. Now we are going to have to find this value. We have negative 8 cosine of x, in this case is 2 pi over 3, divided by 2 minus 2 pi over 3 squared over 2 minus negative 8 cosine of 0 over 2 minus 0 squared over 2. Now, let's work on this. Let's look on this inside part first. So 2 pi over 3 divided by 2 can be seen as times half, as we have mentioned many times. So this is the same as pi over 3. Okay? So what we need to do is to find that. Okay. The cosine of pi over 3 is root 3 over 2. So it's going to be negative 8 times root 3 over 2. This part, the numerator is going to be 4 pi squared over 9. Then we're dividing by 2, so we're multiplying it by half. So essentially this 4 becomes a 2. So this is going to be minus 2 pi squared over 9. So this is the first part. Minus the second part. We have the cosine of 0, which we know is 1. 1 times negative 8 is negative 8. Next, we have 0 squared over 2, which is just simply minus 0. Let's simplify things. This becomes a 4, when this becomes a 1. And then this section right here is actually just plus 8. So we're just simply going to have this as 4, negative 4 root 3 minus 2 pi squared over 9 plus 8. Now, this is the area underneath the graph of 4 times sine x over 2 minus x from 0 to 2 pi over 3. But we only want the shaded region. The region to remove, as we have mentioned, is this section right here. So, therefore, shaded area, we are in the home stretch. Oh my gosh. Okay, so this is going to be negative 4 root 3 minus 2 pi squared over 9 plus 8 minus hold on. Okay, I think that's a mistake I made somewhere, but it's okay. Okay, so actually let's just turn into, this part we can actually rewrite as 2 pi root 3 over 3. So let's do that. 2 pi root 3 over 3, and then minus 2 pi squared over the 9. Minus 2 pi 2 pi squared over 9. Okay, so this becomes when you distribute, you get equals to negative 4 root 3 minus 2 pi squared over 9 plus 8 minus 2 pi root 3 over 3 plus 2 pi squared over 9. So this would cancel with that, but it appears that I have made a mistake. Oh no. Okay, so let me go check on some values first. Let me see if this is... It's 2 pi over 2. Okay, 1. Yeah, okay, so the y coordinate we have obtained to be the correct one. When we, okay, half times base times height. Yeah, and then, okay. I think that's fine as well. Probably something wrong with the integration. Yeah, okay, the triangle's fine because it cancels out nicely. When you integrate 0 to 2 the pi, it gives you a negative cosine, because when you differentiate negative cosine, you get like sine. Let's go to sine. You have to do 1 over a, where a is the coefficient of x. Well, it's like if you were to like differentiate negative a cosine x over 2, you get 8 sine x over 2 times half, so that's equal to 4 sine x over 2. Okay. Maybe the computation was wrong. Minus x over 2. Hold on, yeah. X over 2, the derivative is x. Oh, hold on. The cosine, it's cosine of pi over 3. The cosine of pi over 3 is half. Alright, I see. Sorry. It's actually 1 over 2. Okay, so this becomes negative 4 instead. Ah, there we go. So this is equals to 4 minus 2 pi squared over 9. So in the actual thing, it should be four minus 2 pi squared over 9 minus that. So indeed, when you expand it, you would get this. And so you get 4 minus 2 pi root 3 over 3, which is the question. Yes. There we go. Units squared. Right, so yeah, that's the final answer. Hope this is helpful. Sorry for the mistake. Yeah.